Let's discuss indeterminate forms. Well, to start with, let's discuss determinate forms. These are limits that we know by looking at them. If I have positive infinity plus positive infinity, that's going to be positive infinity. If I have negative infinity minus a negative infinity, that's going to be a negative infinity. If I take 0 to infinity, that's going to be a small number raised to a power. That's going to go to 0. And if I do 1 over that, then of course that's going to go to infinity. It might be positive infinity. It might be negative infinity, depending upon how this limit goes. Indeterminate forms are forms that we don't know by looking. For example, if we get a limit and it's 0 over 0, or infinity over infinity, or infinity minus infinity, or 0 times infinity. We don't know what that is. 0 to the 0, 1 to the infinity, or 0 to the infinity. So we need infinity to the 0, excuse me. So we're going to have to basically manipulate these. Let's start by looking at the indeterminate forms 0 over 0 and infinity over infinity. For what we're about to do, we need our equations to be in this form. So let's look at the limit as x approaches negative 1 of 2 times x squared minus 2 times x plus 1. The first thing you always do is plug it in. If I put in negative 1, this is going to be 2 minus 2 divided by negative 1 plus 1. This is 0 over 0. As soon as you do this, I want you to write the word indeterminate. So you can't do this. So you have just checked. All right. Let me factor the numerator, the limit as x approaches negative 1. I'll pull a 2 out, and it's going to be x squared minus 1, so it's going to be x minus 1, x plus 1, divided by x plus 1. Those are going to cancel, and this becomes the limit as x approaches negative 1 of 2 times x minus 1, and we get negative 2, negative 4. Now suppose I'm looking at a limit that goes to infinity. This would be infinity over infinity. This is indeterminate. Now you remember there's a technique we can use where we divide the numerator and the denominator by the highest power. So this is the limit as x approaches infinity of 3 minus 1 over x squared divided by 2 plus 1 over x squared. Those two go to 0, so this is 3 halves. We have a number of other rules we could have used here. Now let's look at this one right here. E to the 2x minus 1 divided by e to the x minus 1 as x goes to 0. So this becomes 1 minus 1 divided by 1 minus 1. Obviously, this is indeterminate. So let's see, what can we do? I see this is actually kind of a square. It really is. Doesn't look like it. All right, this is e to the x minus 1 times e to the x plus 1. So we're factoring. All right, my e to the x minus 1 terms go out. So this is the limit as x approaches 0 of e to the x plus 1. So this is e to the 0 plus 1, or 2. If I get a function like this, the limit as x approaches 0 of e to the 2x minus 1 over x, when I check it, I'm going to get 1 minus 1 over 0, indeterminate. For this problem, the only way for me to solve it with the skills we have so far is with a table. And it's very apparent that the limit from the left is approaching 2, the limit from the right is also approaching 2. So we can say, based on the table, that our limit is 2.